The velocity of the center of mass of a rolling motion. Suppose a body is rolling in this direction and let this point P be at the ground. When this body rolls, there are different orientations. Let us say body reaches here. In this case the point is now here, this point P is here. Further, when it move, you can see here this point is at the top, then its position is here. Finally, when body complete one full rotation, it again reaches at the ground. So you can see this point P starts from the ground, reaches at the ground. So one rotation completed by the body. It's very simple. One rotation completed by the body. So there is no any difficulty to understand this. This is very simple. Now see, if somebody asks you that what is the velocity of center of mass, this is the center of mass of the body, this is the center of mass, cm, because center of mass reached here. See, if I join, you can see the trajectory of the path like this, like this. Let us say this is the center of mass, this is the center of mass. Now the total distance traveled by the body is s is equal to 2 pi r, that is the radius of the body. Here r is the radius of the body, and this is 2 pi r distance traveled by the body when it completes one full rotation. So it means center of mass reaches from here to here. So velocity of center of mass is equal to total distance traveled by the center of mass divided by time taken by it. So you can write like this, 2 pi t r, and you know this is omega r. So velocity of center of mass is omega r, or simply you can say r omega. So this is the velocity of center of mass when a body rolls. Now see, very important thing, when a body is rolling and point P, any point P on its circumference, let us say its position is here, makes angle theta with a vertical. Somebody asks you what is the velocity of point P, how you will calculate? See carefully, because the center of mass always move in the state distance traveled, state distance. So let us say this is the velocity of center of mass. You are getting my point. And this is the tangent velocity. You know this velocity, you know the velocity of point P is not only due to the center of mass velocity, but it is also one more velocity, that is, you know, tangent velocity. This is also equal to omega r. We already know v is equal to r omega. You say na, v is equal to r omega, that is the same thing. It means if this angle is theta, this is also theta, because this is perpendicular to this line, this is perpendicular to this line. So this is angle theta. Now see carefully, this is also equal to VCM, matlab its value is equal to VCM. Now see, velocity at any point, how you will calculate? The simple calculation is velocity of point P, here it is given by BCM square plus velocity of center of mass, because this is equal to velocity of center of mass. So that's why these are the two velocities, VCM, BCM. It is equal to 2 VCM cos of theta root. This is the way, you know. So when we calculate, you will get root 2 VCM 1 plus cos theta. So it is equal to root 2 VCM 2 cos theta by 2, because we take the root of this thing, 2 cos ke theta by 2 root. Finally your result is root 2 VCM root 2 cos theta by 2. So it is equal to 2. The value of BCM is omega r cos theta by 2. So this is the way to find the velocity of any point on the circumference of a rolling body. Body is rolling in this direction, let us say. So you can calculate any point. Let us say example. What is the velocity here? If the body is rolling, velocity at this point, let us say this is point B. So this is point, let us say P, this is B. The velocity of the body at point B is given by, now see here, this means you can understand very easily. Now the angle between velocity of center of mass and this tangent velocity, like this is 90 degree. So you will get this 2 omega r theta 90 by 2, 45 cos 45 1 by root 2. So you will get here this, and this is root 2 omega r, or you can say root 2 VCM. So this is the simple explanation. You can ask any question. My contact number 7696943521. Thank you.